Hi, welcome to this video on Postgres, Golang, microservices, and Kubernetes. This is going to be a complete video on how to build microservices that talk to a database in K8s and then interact via OpenAPI 3. So if we get started, the first thing I want to show you is kind of the architecture here of what we're going to build. So I like the idea of cataloging films. So this is going to be called Movie Catalog. And the idea behind Movie Catalog is that it will connect to an underlying Postgres database that's also running in the cluster. So what's really cool about this is it teaches us and forces us to make some decisions about, how we're going to connect, where the strings get kept for that. Also, how's our data format going to work, and how are we going to start to work between OpenAPI and gORM, which I described a moment ago. And I'll go into more detail about what that is. And then, on top of this, there's also the server-side implementation. So we're going to have a server for our OpenAPI spec. Starting simply, what is the objective here? The objective is to help you get a full stack understanding, really, in terms of what would you need to do, and what are some of the technologies that can help you to build microservices very rapidly that have a lot of value, right? And the idea with this particular microservice is that you can use the OpenAPI spec to interact and store data and fetch data. Now, the way that I want to show you that is by actually showing you the Swagger editor here. Let me just blow that up a little bit. So I'm using an online tool called editor.swagger.io. It lets you take a Swagger file that you can either write or you can upload, and it will then render on the right what that file will actually do. And it's a little bit like Postman, if you've ever used that. You can actually call or make some of these requests with the try it out feature, so you can pretend to hit a server, and that's quite useful. OpenAPI spec is a great standard that you can build APIs around, and what's particularly cool is that you can backwards generate both client and servers from this. So I started with complete basics here. So what I'm going to do is I've got a new project, and I called it Movie Catalog. I've got nothing in here. The only thing I'm going to do is in my root here is I'm going to put my swagger.yaml, and I'm just going to copy this Swagger YAML and paste it in. As you can see, I made this before the video. It's really simple. I mean, all it has is 4 get commands and 1 post, and it has a component down here which has the movie and the error. Now, these components are YAML objects that can be converted into structures in Golang. Now, how do we do all this? Well, we'll come to that in just a moment. So you'll see that I've got another tab here called OpenAPI Client Gen, Code Gen. This is a project that allows you to take a Swagger file and to generate a server from it. Now, I mentioned a whole bunch of other stuff such as Postgres and Kubernetes and getting all there, but before we do, we have to have some sort of server or some sort of service we want to run. So let's go through this document here. I can see that it says it wants me to install something, so that's just fine. I'm just going to, in my other tab, bring up my terminal so we can work on this together. So as you'll see, I'm in this file, in this folder. I want to grab with go install the latest code gen. Now, I already have it on my system. So now I want to do is this code gen into codegen.go. Right, okay. Now, that's really useful. However, I also need to think about what I want the generator output to be. So if we look at the code gen here, you'll see there's a bunch of different stuff we can generate. And this is important because I mentioned we can do a server, we can do a client. Well, we need a few things. We need the types. So as I said, we need the movie type. We also potentially need the server because that's super important. And we might want to do the spec as well. So in between drinking cups of coffee, let's have a look at what this means. I'm a fan of Echo server. Echo is a super lightweight Golang server, and it gives you a little bit of explanation on how to get that set up. So let's try and do a generation step. So if I go into this right now, we're going to go paste that in. We're going to go generate. I'm going to put types server, and then if I put the Swagger YAML, I'm going to call this server.generated.go. Okay, so generate isn't supported in the new style, so I've got to pop this old style config. I seem to remember as well that I also need to change this from saying old style to actually old config style. I think there's a slight something missing there in the docs. They've got style instead of config. So let's go ahead and try and fix that and see if that works. It's also 1- here, but let's just try 2. Package name needs to be specified. That's fine. So this is the package that's going to be generated. Well, I'm doing it in my main, so I guess I could call a package main. So now that's generated. However, we're going to be running this a bunch of times, so it probably makes sense for us to copy this. Now, one other thing we could do is, rather than writing a shell script, we could put this inside of a Go generator. So if I go to my main.go, and I'm going to make all this stuff a bit bigger so everyone can see. Package main. Right, so that does nothing. However, at the top of this, we can put a go gen. And the go gen command, if I actually remind myself the syntax, then next time we go to the CLI, we type go generate. First thing we need to do is go mod, so we'll go mod init. I'm going to call this movie catalog and just give it a relative path mod. Go mod tidy. So now it's pulling in echo because that's inside of the references. But doing this generate here allows us to run go generate rather than having a shell script to do this, which is really idiomatic and clean. So let's try that. So if we go back to this code gen piece, we kind of need to figure out how do we actually use this, right? So we've got this generated server. What does that give us? Well, that's taken the YAML structure for movie and for error, put those into types. It's also built a bunch of handlers for us. However, we still need to connect the dots in our main.go. Inside of this library, there is a good section on examples. So if we look at pet store expanded, there should be a bunch of different server implementations. We can see here there's the echo server. So we can see we've got pet store. So down here, we could more or less take most of this. So let's go down to here. We'll import what we need to. The port has been imported. It's not being used yet. API.swagger, that will also need to be added. So that comes actually out of the server generated. So that bit we don't need just yet. That would be inside of getSwagger, like that. Now, if that getSwagger isn't working, that is most likely because we're not also generating the right components. So we'll go back to that in just a sec and have a look. So what I'm going to do is I will also make sure that when I do my generator step, I do the other pieces that were missing. So I think that was just client. So let's have a quick check. So if I paste an H in there, I can see that I've got types server, but I was missing spec. So spec is the thing I believe I need to make that command run. And the reason that's important is that's what it validates against. So let's try that again. Okay. getSwagger now is okay. I will also just amend the main.go for later on when I fix this to put spec in there. Okay, so both these things are importing but not using. But what we can see now is clear out. Okay, so create an instance of the handler which satisfies the generated interface. So this is where it might become confusing because suddenly it's like, oh wait, what am I doing now? So let's just take a step back. This generated code, what this actually gives you are the handlers for the incoming HTTP requests. So the handlers get generated. However, these handlers are behind an interface. They actually need an implementation to do stuff, right? So business logic in the implementation, that is up to you to build. And that's what this is here. That new API pet store satisfies those handlers. And if you'll see that what happens here is when we register these handlers, we're registering the Swagger spec inside of the generated code against the handlers. So I'm going to create a new file and hopefully it will start to make a bit more sense. So I'm going to go server.implementation.go, right? Package main. Right. So this is going to be where I start to implement the actual handlers for this. So if we look at some of the handlers, here we go. So this is the server interface. And what we need to do is we need to implement all of this stuff. So what I'm going to do is I'm going to create a type server implementation. And that defines the server interface. And now what we can start doing is we can say server interface, server implementation, sorry, get movie by name, for example. We'll pop that in. And you'll see my autocomplete is helping me be a bit faster here, which is really useful. And then we want upload movie, which is our post. Get Swagger, we don't need to implement because that comes from the generated file. So the thing that's wrong here is that it's returning the interface like that. We will just for now return nil on these handlers. And it's actually the context that you set in the return to modify the HTTP response. So there we go. So that's our implementation. You don't have to put the server interface like this as an inherited part of the implementation. And in fact, just to avoid being misleading on why I'm doing that, I will get rid of that. So let's try and figure out what we're going to do. So you can see here on the right, if I glue this to the center of the screen, we set the Swagger service to nil. We then take the server impl and we create a new server implementation. Here they're actually using a function. We can just implement it directly like that. Then what they're doing is they're going echo.new. Now echo.use. Now using the echo middleware .logger, which is great. There's a whole bunch of middleware that we can pull in. One thing I would say is that we do need to make sure we actually have it imported properly. So when I go back up to here, we will ask the IDE to grab that. Sometimes the IDE doesn't grab it, but there we go, I think that's worked. And we also need echo itself, which is in a different part of the package. Okay. And now what we're going to do is grab the other two bits and just replace them with our own values. So we've got the logger. We also need the middleware for Swagger. And again, this is another implementation link. That middleware is coming from the CodeGen package middleware. So that one, I think is like that. There we go. And that is actually linking Swagger in. So it's creating the correct kind of HTTP handler to validate the incoming HTTP requests against the spec that you've defined. And then the last part here, rather than register handlers on API, we're doing register handlers against server impl. So what we're doing is we're telling it, hey, the server interfaces here are being implemented in here. So let's just see, we've got an error. So we don't implement get movie by year, which is nice because it shows us really easily. Function get movie by year. There we go. So now we go back to our main. Let's see what it says. It's a pretty obvious one there. We have the integer, but it wants an int64, not an int32. There we go. So now it's going to start the server against our default port. So let's try that. Bunch of errors. Okay, so go get. There we go, so that actually runs. Now, how would we write a request? Well, in another tab, let's go curl localhost 8082, and that would be looking at our spec. It's going to be something like movies name / name. Let's call it something like Thor, and nothing comes back, of course, because we've not implemented any of our handlers, which is absolutely fine. You can see though, however, we've registered the request here on the left. What I also want to do very quickly is I've noticed that we're on the wrong Go version in my Go environment here locally, so I'm just going to switch to 1814 and do a reload. And then what we'll do is we'll start debugging. We have to create a launch file because we're using VS Code, so we launch process. We're going to switch this to dot on the program name. There we go. I'm just going to, in another screen, enable my developer tools. Okay, let's run this. Okay, address already in use. That's because I probably didn't exit cleanly on that process. Let's go to 881. There we go. Now, if we want to just check that our implementation is working, let's go get movie by name. Hit this again. Okay, so that's the wrong port. That also shows me that that server is still running as a background process. There we go. So at this point in time, you can see that Thor's come through in the context, and we are correctly able to get our film, which is great. However, this is just the most basic part of the implementation. We need to start thinking about running a database and doing all of that jazz. So what I will include in this video, and with the repository that goes with it, is a small script to help you get up and running. I've taken this from another project I've done, and it's been really useful. It's an installer for Postgres. This installs Cloud Native Postgres, which comes from Enterprise DB, which is pretty sweet because it just works. I don't have to think about it. And what's even better for you is you literally just run scripts install Postgres. Now, I've already done it on my local Docker K8s, but this is kind of what it looks like. You can see that it's got a cluster in there, and it's also printing me out the token for this as well, which is really great. However, I don't want to cheat, so what I'm going to do is I'm just going to tear mine down. So if I go to my cluster, I'm also going to check that Postgres is being deleted. I think it might be a stateful set or a daemon set. I don't know what it is. There it is. There we go. So that's closing down. Then we'll do a reinstall, just so you get the full experience in this video of actually what creating a new cluster might look like. Okay, you can see we've got a new token. What I'm going to do is I'm going to set that as a token that is an argument here. And we're going to call it Postgres key or password. And that will be just in my VS Code. Also really important to make sure VS Code doesn't get committed into Git. So at this point we have a remote Postgres cluster that's just been set up in my Kubernetes. And I should be able to see that if I type cluster. There we go, MovieDB cluster. I did some work before this and I named it and things like that. So there's my cluster, and you can see actually, if you go to the bottom of that script I showed you, that's the CRD that lets you control it. You can see that there's a database called movie with an owner called app. So we go back to our design now, we're starting to look at this ORM Postgres bit. So when we want to use Postgres locally, part of the trick is you need to be able to port forward, right? Because it's in a K8s cluster, whether that's remote or locally. So what I would do is open a tab and figure out what you're port forwarding. So we get services. The one you want to port forward is this read write. So it's the MovieDB cluster read write. So if I go kube control port forward, I want to go then service, and the port is 5432. There we go. To test this works, if you've got pSQL installed and you go -h, help even, you can test that connection. So if we look, you can see that you've got a bunch of different options. So hostname, port, username is the important one, app with password, and our password we saved in the launch configuration here. And the last thing we should need is our database name. The database name should be somewhere here. Okay, so we're now down to an authentication issue, which is half the problem. So let's go and check to see if our password's correct. There we go, and we're in. So you can see that the Postgres connection is working, and pSQL is a nice way of checking that. So we've got that open. So I guess the way we could describe it is, if that's our K8s cluster here, what we're doing is we're opening a port forward so that we can do local development. On our machine here. Okay, so we're leaving that open. Now there are a few things we need to figure out next. It's like, first and foremost, it's what do we want to store in this format? So it's pretty easy in this example to understand that the movie object is what's going to go into our database, and that's going to be its own database with a bunch of really easy to map fields, right? Because you've got strings, we've got integers, and we have arrays of strings. What's important to understand is that these types aren't one-to-one between OpenAPI and gORM, which is what I want to use here. Before I talk more about that, I just want to take you through what gORM is. So, firstly, ORM stands for Object Relational Mapping, which takes a struct or a class, an object instantiated, and maps it to a database table. And what's super useful is that it means we have to do very low amounts of actual database-centric queries. So I'm not writing much SQL at all. And as you can see here, there's a bunch of other things that are super useful. The thing today that is going to be the most useful is the auto migration for us, which migrates that type into the database. So you can see these are the things we need to do to install. However, we're not using a SQLite database, we are using a Postgres database. So we're going to go ahead and try and find that in the docs. SQLite is a file-based implementation locally that differs quite significantly from Postgres in the way that you connect to it and also the implementation behind it. I like using Postgres purely because it's free, it's straightforward, and it's highly available. So you can see we also need the driver for Postgres. So let's go back to our main.go and figure out what needs to happen here. We have this whole piece around gORM open. There's a whole bunch of stuff here. We don't need half of this. And then you can see it connects. So let's actually try and find an example. So what I want to do is, rather than just looking at these docs, I do think that gORM also does have a couple of projects that are useful to look at. One of which is called gORM Datatypes, or gORM Datatypes. This is useful because it actually shows you how to perform slightly more intricate queries. But there's another one, which is the actual gORM GitHub itself. Here we go. And this one has some examples, I believe. I think what we need to do is root them out. There's a quick start, and if we combine the quick start, getting started, overview, connected to database, if we combine this with the Postgres implementation piece, then we should be able to get going. I guess this is it for now. So let's grab this. We're going to put this into our main.go. We are going to do, the first thing we're going to do is check to see if we can actually start connection to the database before we do anything else. Because if we can't connect to the database, then starting the server is just a waste of resources. So in this case, we are on a local host connection. We are using the user of app. However, all of this stuff is going to be dynamic and change. So I think it's probably a good time for us to start thinking about hoisting our variables out. So we've got port, and port is, what is that? That's an int. Let's now also add Postgres user, and that is going to be default to app. Postgres password, blank, and then Postgres host, localhost, and we'll just start to replace some of these things. Oh, DB name as well, and port. So what I would do is I'd wrap that in a format sprintf. So we'd start with Postgres host, Postgres user, Postgres password, I think it was. Postgres, we don't have DB, so we'll just put movie. and port, and it's not movie catalog, it's movie. This is where you've got to be really careful with auto-completion. Sometimes it will just put the wrong thing in. Okay, so let's just break this up so you can see it a bit better. So that's our connection string, and then here we have an unhandled error. We also then see that the error is also duplicated. Okay, what's going on here? So it looks to me we have an issue where DB is probably not being used. That'd be right. This looks almost like a incorrect character. Oh, I see. It's because we've got this comma at the end here. Okay, so we're now getting a bunch of other names. This is looks better. So let's go and see what happens. So the Postgres password is being passed in. I need to now suddenly process those things. So I need to use flags. So what I want to do is, in the same vein as the here, I'm going to say Postgres password equals flag.string. There we go. Okay, now let's just check to see if any of this works. The first thing I want to check to see is actually does the password even set. Let's go through this again. So now if I go to my next step, I have connected to the database, which is great. There we go. So what we can do now is, now that we've connected to the database, this is where we're going to do some interesting stuff. We want to auto-migrate the data. So we want to auto-migrate the movie so that it creates a table within the database for movie. So what you would think you could do is just go auto-migrate API movie. However, we might find we get some issues, but let's have a look. Let's see what happens. So unsupported data type, ampersand array. So what that actually means is that the array of strings here isn't a supported type in Postgres. This is where the gORM data types is super useful, because I went through this and I found there was a PG string type that would support exactly what we need. So I'm going to have a little root around to see if I can find that again. Maybe memory will help me out here. But I seem to recall I need a library for this. So I'm going to just check Golang PG string var. Let's have a look. This might be it. Actually getting the Postgres toolkit directly. Yeah, I think this was it. We'll check. I also have an inclination that I have it in another project. So let's go and take a look. This is a slightly different project, but it works in a similar kind of way. Let's take a look. Okay, so it is PQ string array. That's the thing we need. And that comes from libpq. So these are the weird idiosyncrasies that aren't super obvious when you start doing this stuff. So let's grab libpq. We're going to take that as a string array. So what we will do is go into package, into generated. Now this does mean that you're modifying the generated script. However, you shouldn't need to generate this again. It is a caveat though, right, that you're doing this. You could create a DTO, so a data transfer object, that you change from one format to the other, but for the sake of this video, I didn't want to do that. So here we go. We've got our PQ string array. Another thing that I've done in this other video, this other thing that's useful, this other project, is I've added the gORM hints, so telling it's a text type. And that should be it. So let's go ahead and try that now. So if we go back and run this, you'll see that it's auto-migrated correctly, which is pretty cool. So now we actually run this completely. Well, what does this look like? So if we go back to Swagger, you can see that uploading a movie should look like this, right? And this is super useful. So we'll call it Thor. Oops. We will call it Thor once we do it. I can't remember when that film was made, but anyway. So we'll go curl localhost, in fact, xpost, right? Localhost 8081, and then it's movie, I think, upload movie. It's just movie. And then you're going to go D because we're putting an object in there. And I've got the entire object here. Now, what you can see is that one's JSON. Here we go. So that's kind of the same thing, except for I've set the content type to application JSON. Now, if we now try and hit the implementation here, we can see that data comes in on the path movie, and it's on the request, and we need to really convert that back into something that we can use. Otherwise, it's worthless. So let's figure that bit out and see what we got to do. So at this point, it comes down to how the Echo framework works, and this context object is what contains everything. So what we need to do is we're going to call it new movie, and that's bound to movie, and we bind new movie. There we go, and basically that converts the body payload back into the structure. And at this point, we need to figure out what the next bit is we want to do. So let's just run that and check if that works. Okay, so let's turn this off. Let's go ahead and post that video. You can see now that if you look, we've got that bound to the struct, which is great. I'm going to start putting these things in the README to make it easier for myself going forward. So post. There we go. Before we get too far into this, it's really important to remember that you want to keep these operations atomic. So that means that we probably want to have a lock inside of the struct. So if we go call this lock, that's a sync mutex. What this does is it creates an exclusive lock on this for a short time. So what we want to do is we want to call s.lock.lock defer s.lock.unlock. So at the end of this function, it will now unlock. And now this is really where we have to start thinking about how we're going to use gORM. Now, what's really cool about this is how easy this makes our lives. So what I'm going to do is just go s dot something. I need the movie database passed through. So that's db, and that's going to be gORM.db. You can see how the completion tries to pass through all sorts of random things. That comes down to the server implementation here. There we go, pass that db in. Now where we are. db dot, so it's s.db dot, I think it's create new movie. Now we probably want to have a return on that, so that's the transaction. And when the transaction is complete, okay, and that's right, and we probably want to return nil. Okay, a lot of things happening there. but I hope that all makes sense. So we convert the payload into an object, we lock locally, we then do a db create, and then if that creates successfully, return status code. So let's try that. Okay, so that hit the OK. There we go. Now, we actually want to do something a bit more interesting. We want to figure out if it has that actually created. So let's go get that movie by year. So what we will do is we will do the same thing again. Now, this is where we actually need to look at the gORM syntax a bit. As you can see, we've got, this is using SQL native. We don't need to do that. What we do need to do is look at how to use the where function. There we go. So you can pass in a field and match against that field directly. So if we're going to do that, we're going to say var movies, because there'll be an array of movies if we search by this, because we're not doing a first. We're going to do transaction s.db. Well, that's pretty accurate. There we go. So where year equals passing in year find movies. And year is from the implementation here. So that was a good guess. Now transaction. That's great. Otherwise, pass back the list of movies. Wonderful. What's really nice is it also converts this into JSON for us. So should we see if that works? So now let's go curl HP localhost 8081. Now I've got to check the command. So that was movies/year. Movies/year. Now 2016, I think. Pop this in. What have I done wrong here? There we go. Just pop that into JQ. And you can see that we're actually getting the film back out in the database. So I'm not going to implement any more of this because this is the bare bones, and hopefully you can see how you can do the rest of this on your own. But what I will show you is how you actually get this into a cluster, right? Because that's the next challenge, is like, how do we put this as a pod in a cluster? So what we want to do is create a Dockerfile, right? That's probably the next step. But then, you know, it's not just as simple as creating a Dockerfile. We need to think about, well, how's this going to work? So what I want to do is I want to think about, what am I pulling from? So let's say we're going to use Golang 1.18, Alpine, it's Builder. Now, these are great abilities in the OCI part to actually do multi-part builds. That's a great way to optimize and to reduce your footprint down. So now what we'll do is we'll add the current directory into source, we'll set our work directory. This is very important for the modules. Into source, and then we'll do a run cgo enabled. Build this for Linux. We are on ARM64. That's my local computer, it's on ARM. We'll do a build, and we'll go we'll call output movie catalog dot. After this, we will then from Alpine, and this is where the as builder comes in. So you see you've got this copy from builder. So what it's saying here is we are doing a copy from builder, source, movie catalog. That's actually a pretty good suggestion. We'll set this to user local bin, expose our port, which I think was 8081. Yeah. And then we will set the entry point as movie catalog. In fact, I think that will have to be set like that. Let's try it. So this might take a little bit of time. It's got to pull that image, and then it's going to build all of my dependencies. And then we can test to see if that works. In the meantime, it's probably worth cancelling the running process, Okay, so one of the things I didn't do was I didn't name the image. So we're going to call this movie catalog v1. And that should take no time at all because I've got most of the layers already stored locally. The interesting thing here is that you see because the Go build is a single layer, it is having to pull in all the dependencies again. Whereas if I'd split that and did a mod tidy first, it wouldn't be the case. Okay, so catalog v1. Oops. Doing a Docker run, which is great. We can see it's working, but of course there are problems. Cannot assign address, etc., etc., which is absolutely fine. This is because we need to provide this. So because we're going to wrap this in a pod, we don't want to do anything with a Docker image. We're going to pass these in as arguments on the deployment, which means that when we create that deployment, we can pass those through dynamically, which gets us to the next place in this video, which is how do we do all that? And as we come up close to an hour, I will try to be succinct. So we've got our working implementation, we're connecting to a live Postgres. However, we need to now figure out the whole shebang of deployment. So we're going to use a Helm chart, and in here we have our Docker image. In fact, I want to be super accurate on this picture. What we're doing is we're building that, but we are creating a Docker image out of that, or an OCI, and then that has a manifest, right, as well. Templates. And then we will deploy this into clusters. So we've used the name movie catalog already. Now, when you do a Helm create, that name you probably don't want to duplicate, but we can, and then rename it. The reason why calling it movie catalog is important in Helm create is because that's what the service name becomes, that's what the deployment name becomes, that's what all of the notes and helpers in the templates become, and we want to call it what the name of the service is. So let's create that. But what you'll see actually is you get this error, which is because it's inside of, oh sorry, it's got a binary inside this directory, so let's delete that. Okay, what you will do though is move that. So at the root level, it's not nested and super confusing. We'll just call it either chart or Helm. I'm going to call it chart. So there's the Helm chart in there. So what I think is a good thing to do right now is to build a bit of machinery around how do we start producing images. So let's create a make file. Docker push. That's going to be Docker build. And then -- push. The image name is going to be, what do we call it? So I'm on my CN Skunkworks account, movie catalog, v1. I have very little faith in anything I write, so let's just make sure that works. Phony just tells you that this isn't a file. It's sort of a make file idiosyncrasy. Well, that didn't work because I believe that needed to be wrapped. There we go. Flag is not. Oh, I think flag might be a Docker build X command. I'm not totally sure on that, but yeah, we can do Docker push image name. That should work as well, right? And so this is just building that machinery so we can start getting out this image onto Docker Hub and then consume it in our chart. And I'll finish this all off by showing you how this works in cluster. There'll be some things we need to modify. For example, okay. I'll just do a direct push for this time, and then we'll come back to that. I had a T argument, which I didn't need. So in this case, we'll just do a push. There we go. So yeah, we need to get the Postgres information into the running deployment, because even though it's in the same cluster, it will have a key that it needs. So the way I would do that is set it as a value. So let's create all this stuff and figure out what we're doing. So the repository is going to be this. The tag is going to be v1. Now let's create Postgres. Postgres user app DB is going to be movie. Password won't be set. Okay, so that's what we'll pass in with the makefile. Now, to get the password for the database, we just need to look inside of the secret that gets created for the user. And that sounds super complicated, but it's really not. So keep and go get secrets. You'll see that we have a basic auth secret for the user of app. And what's cool about that is that's something that we can actually fetch when we need it. So what I'm going to do is I'm going to do a control get secrets movie db cluster app JSON path equals data.password base64 decode, and then I got that password, and then I need to pass that into my Helm chart. So what I would do is a deploy. I'm going to go cd into our chart, and Helm, I think it's going to be an upgrade install is probably the best way to do it, because in that, if it's not installed, it puts it in, otherwise it upgrades it. Upgrade install, I'm going to call it movie catalog dot, and then we're going to do set equals Postgres dot password. Fascinating that it puts that in there. And then in here, we're going to run this command so that injects the correct password into the Helm chart, right? Postgres.password, Postgres.password. That's only half the story. We then need to get that password into Postgres. Now, probably the best way to do this would be to create a secret, and that secret you would then mount in the deployment. For the sake of time, I'm going to just pass it in as an argument, and I would never advise doing this in production because that would show the password in the deployment. As I said, the best way to do this would be to create a secret and pass the password into the secret, but just for the sake of time, I will do it here. So let's just carve out the things we don't need right now. I don't need a horizontal pod autoscaler. I don't need the tests. I'm just going to come down to here. Now we've got the containers. Here's the image itself. We want args. Now what we want to do is pass the Postgres password in, right, as an argument. Ooh, it's giving me a bunch of stuff. So Postgres password equals, that's slightly incorrect, that, because it's tried to, and I think that might be lowercase. Let's double check. Yeah, it's lowercase. Right, Postgres.password, that gets passed in here. So, oh, there's a spelling mistake here. So what you can see now is when you run the makefile to install, that will dynamically fetch the Postgres password. It will pass it into the deployment as an argument. That argument then get passed through to the main. We also need the host name because localhost is not going to work. So host name should work in the same way. However, we don't need to pass that through dynamically through the makefile. We can just set that on the values. So we're going to call that host name, host. Host for Postgres is going to be RW. Now, because we're in the same namespace, I don't need to fully qualify it. So I'm going to call it that. Again, I also need to pass that through as a flag. So Postgres, now what do we call it? Do we even have it defined? We do not. So Postgres host equals flag.string, Postgres host, localhost, perfect. You can see this is why I want to industrialize this a bit. Postgres host gets set as Postgres-host. That will set in deployment. Let's see what madness it's brought into the autocomplete. So we've got, it's given me all of the things I didn't need, so let's just do the things we do need. Values.postgres.host, I think it was. Let's just double check that. .host, okay. Now we'll need to make a new Docker image. We could just overwrite the old one, but why not make a new one? Make Docker push. I'll also need to make sure that I'm passing the right image version in. So, probably the nice way to do this would be to also set that. So it would be set image.tag. v2, like that. Okay, so some of those layers already exist. The other one's pushed. So let's give it a run. Let's see what happens. Let's try and deploy this. So we can see that it's gone in and it's installed. Let's have a look and see. There's our Helm chart there, movie catalog. It's got a crash loop. Okay, so the first error is that there's a dial issue because the address is wrong. So you can see that we do have a problem here. Postgres password never got set, which doesn't help anything. So let's see if we can fix that. So if I go to run this command again, let's check and see whether the command is broken. No, command's working. Have we put it in the wrong place? So set postgres.password. It should be postgres.password. That's fine. We can just set that as nil for now. Let's go to deployment. We've got now values postgres.password and postgres.host, which all look good to me. When this sort of thing happens, I mean, my suspicion immediately goes to syntax. And the thing I can see that's happened here is when you want to execute something in make inline, you need double $signs. So that's the world we live in. So that's what's gone wrong there. So let's make deploy again. Let's try that again. I might need to delete that deployment, which I will do right now. Okay, let's try again. And I'll delete the Helm chart as well. Okay, let's give that another go. Now let's just check. So here you can see we have the password set, the Postgres host set as well. Let's see what happens. Okay. Well, I can see that it's saying localhost here. So do we have a code issue? We probably have a code issue. I suspect we have a code issue. So Postgres host. What probably makes sense would be for me to test this locally. So what I will do is just that. But prior to that, I just want to triple check that I've got the right parameters here. Postgres host, that looks correct. And that was correctly being passed through as well. All right, so let's try and do something different. Let's check to see if that actually works. Put a new argument in. Foobar. Let's run that locally. We should get a panic. Foobar doesn't work. So when that kind of thing happens, now I did have the default parameter there set. Now I'm going to remove that default parameter because the default parameter might have been passed through and disguising an error where we're not actually setting the correct parameter externally. But that said, let's try it again. So I'll set this to v3, or we could overwrite. Also, I'm a little suspicious of this set image tag working correctly. Let's just double check. Image.tag. I won't set a default tag just to be sure. And we will do a make Docker build. Push that image up. It's not that I don't think that this stuff works properly, it's more that I don't trust myself, and so this helps me to eliminate the issues. Also, the pull policy, when you're developing, I would pretty much always set it to always, otherwise you can end up with stale images, especially if you're rebuilding on an old image. So there we go. Okay. Okay, now let's try and do the deploy. Okay, container creating, there's an error in that. So you can see the host isn't set. That's what's happening. The host is not being set. It's set as, well, there's a whole bunch of stuff happening here that looks incorrect to me. So if we just wrap this, user app, it should not be the host. So it looks to me like the string is empty for the post. Let's check and see what's getting set here. Oh, and so here looks to be the issue. The argument is on the same parameter as the password field, which is not correct. So what we need to do is to go here and add it as a second arg. So there you go. A very simple answer to a very tricky to find problem. So let's run that Helm chart again. We might need to reinstall it. There you can see now they both have their own positional args. And it's running. Let's do a port forward. Now we should be able to get the same data that we did because we're connected to the same database. So I'm porting that on 8084. I want to get 8084. I'm not sure what year I actually set in here. 2016. I think that's the right API. Let's check. Localhost 8084. Is that port forwarding correctly? That's right. Movies, year 2016. Now, let me just remember, did I actually implement that? I did. Let's check on the server side. Oh, I see. I've still got 2 services that are registered, so I want to delete the service that's failing. This looks like the replica set didn't clean up correctly. And also, the one that I'm running is crashing, so let's see what's going on here. Looks like it's had a pod restart. Alright. Let's see if we can figure something out. Right, so in this case, it looks like there's an issue here. Okay, so the final issue we have is that the service isn't running because their liveliness check is failing. If you go to deployment here, you'll see that there's a default liveliness and readiness probe. It's not letting the server receive requests because this is failing. Also, I can see that my port is incorrectly assigned. So that needs to be 8081. It's interesting how this isn't passed through by Helm. And the value service port also needs to be assigned. Oh, I don't know where that even is. There we are, there. Okay. I'm pretty confident now that if we get going, again, I will delete this. There we go, that's gone. Good. New replica set, come up. New movie catalog. Okay, let's try again. 8081. And there we go. So I hope that's been useful. We've basically managed to get a microservice that uses OpenAPI. I showed you how to generate the OpenAPI to create a server. And then what we looked at was how do we create a Postgres database. That Postgres database is just a Helm chart that installs one in the cluster. As I said, it's cloud native PG. And then we used gORM to connect to that. We put it all together so that OpenAPI, we modify the object and we can inject that then into gORM and then into Postgres. And then I showed you how to write a Docker image and then a Helm chart. And eventually we wrapped it all up and deployed it into our cluster. I really hope you've enjoyed this video. There have been a bunch of mistakes, but I actually think that's a nice thing to have because it's not super edited. So I think that took me what? That was, let's check, an hour and 12 minutes of talking. And I hope that you can take the bits that are useful. Any questions, please let me know. Please do like if you found it useful because it means a lot to me. And yeah, I'll see you next time. Thanks again.